So here we really need to make sure that we know our rules, but we need to visually be able to see what's going on with our picture. So for this first one, there's a couple different things. It could either be a translation, a reflection, a rotation, or a dilation. So to me, it doesn't really look like it gets much bigger or smaller. So I'm just going to rule out dilation. I can also see that if I was just doing a translation, that would just be this figure, my pre-image, going up or left, down, but that's not the case. So it's definitely not a translation, and it's definitely not a dilation. So now we need to figure out if this is going to be a rotation or a reflection. So if I was to reflect over the x-axis, then this top triangle would come down, and this bottom triangle with the little piece would go up. As if I were to fold it on that line, it would line up with the image, which is not the case. It's also not the case for when I fold over y. So this is not a reflection over the x-axis or the y-axis, and it doesn't really seem to be a reflection over a line y equals a number or x equals a number either, which would be similar to the x-axis, just up, or similar to the y-axis, just over. That doesn't seem to be the case. So I'm going to test out an idea that maybe this is going to be a rotation. So the way that we can check to see what degree rotation is going on is I'm going to assume that my center for rotation is actually the origin. I'm going to draw a line from X to the center of rotation and from the center of rotation to X prime. Do you see that bold line that I just created? It looks like a 90-degree angle. I'm going to double check that with another set of corresponding lines. So if I go from Y to my center of rotation, and I go from my center of rotation to Y prime, it also looks like a right angle. Let me zoom in a little bit. So it looks like this is a right angle, and it looks like this is a right angle. So I'm going to assume that this is a 90-degree rotation, but if we basically know the rules for our counterclockwise, I need to make sure that this is actually moving counterclockwise. I'm going to start with my pre-image. I'm going to start with my pre-image and move to... So I'm going to start with my pre-image and move to the image. So if I move this way, that's the same way that a clock moves. That's going to be a 90-degree clockwise rotation. Our rules the rules that we learned deal with counterclockwise. So instead of a 90-degree clockwise rotation, that would be the same as me going all the way around the other way, which would be 270 degrees counterclockwise. Now we can write the rule. We can say 270 degrees, find the opposite of x, switch the x and the y. Or, if you didn't want to do it like that, you could have written out all of your coordinates for x, y, w, I think this is a z, and then compared them to your x prime, y prime, w prime, and z prime. And you could have said, okay, my x is at 1, 2, and x prime is at 2, -1. All right, so my x and my y switched places, but I took the opposite sign of that x, which is the same rule we came up with here. If you don't remember the rules, just compare a couple of the points and their from the image and the image that correspond.